Welcome to PM Ready, your guide to becoming PMP certified. This is part 3 of Earned Value. This lesson will cover the 3 basic approaches to forecasting. But first, you need to become familiar with Budget at Completion, or BAC. This is simply the total budget for the project, including contingency reserves, but excluding management reserves. BAC is, of course, the baseline budget for the project and is naturally used in forecasting. The Performance Measurement Baseline, or PMB, is the time-phased plan of how much will be spent when. It is the budget divided into time periods and represented by the PV line on the earned value charts, such as those in the previous lesson. Because PV is the planned value of the work as of the point in the project that you are measuring it, the PV of the whole project equals the budget at completion, or BAC. On the other hand, the estimate at completion, or EAC, is the forecasted total cost or time of the project. The estimate at completion will generally be different from the budget at completion, because unless your project is exactly on time and on budget, your forecasted cost and time for the project will be different from the approved baseline. There are 3 basic approaches to forecasting. One is to assume that the project will continue as it has been. The second is if there has been a problem but it's been fixed. And the third is to re-estimate from the ground up. In the case of the problem being fixed, it also has a few variants. You may have fixed both the cost and schedule problems, or you may have only fixed the cost problem, or only the schedule problem. First, let's cover the continue as it has been approach. Whether schedule performance or cost performance have been better or worse than planned, if you expect that the performance will continue as it has been, then you can use the schedule and cost performance indices to adjust the project forecasts. Using our example project of scanning documents, after 2 days, only 1 day of planned work has been completed, and it has cost $4,000 instead of $1,000. The budget at completion is $10,000. The planned value is $2,000. The earned value is $1,000. The actual cost is $4,000. The earned schedule is 1 day. The actual time is 2 days. And the cost performance index is the earned value divided by the actual cost, or 25%. And the schedule performance index is the earned value divided by the planned value, which is 50%. The schedule performance index in terms of earned schedule is also 50%. It's the earned schedule divided by the actual time, which is 1 day divided by 2 days. If you expect the project will continue as it has been so far, then you can simply multiply the performance indices by the original plan. Instead of 10 days, you can expect it to take 20 days. Instead of $10,000, you can expect it to cost $40,000. The forecasted total cost is called the estimate at completion, or EAC, which is defined as the budget at completion divided by the cost performance index. In this case, $10,000 divided by 25%, which yields $40,000. Naturally, forecasting the total time is done by applying the schedule performance index in earned schedule terms to the planned duration, or PD, of the project. So the estimate at completion in terms of earned schedule is the planned duration divided by the schedule performance index in terms of earned schedule, which is 10 days divided by 50%, which equals 20 days. The little t after the EAC variable indicates that this is the earned schedule version of the formula, which is measured in units of time rather than in money. The estimated variance at completion, or VAC, is minus $30,000. The formula for variance at completion is the budget at completion minus the estimate at completion. In other words, what you have planned for minus what you think it's really going to take. In this case, $10,000 minus $40,000, or negative $30,000, is the variance at completion. In terms of earned schedule, however, the variance at completion is the planned duration minus the estimate at completion in terms of earned schedule. So in time rather than money, this is 10 days of planned duration minus the estimate of 20 days, which yields minus 10 days of variance at completion. In other words, the forecast is that the project will be 10 days late and $30,000 over budget. Now let's consider the second approach to forecasting, in which you assume that the problem has been fixed. Now, it's important to be careful with this one. It's easy to be overly optimistic and think that poor performance problems are behind you. However, if you are quite certain that your project's past performance problems have been resolved and that future work will progress as originally planned, then you can use a different formula. Suppose, for example, that the higher costs and delays of our example document scanning project were a result of not having the proper equipment ready on time, as well as higher setup costs. At the end of day 2, if the equipment is now in place and setup is complete, and you are confident that the project can now proceed as originally planned, then you can simply add what has been spent so far, that is $4,000 and 2 days, to what you expect to spend to finish based on the original plan, that is another $9,000 and 9 days. The formula we use in this case is EAC equals AC plus ETC. EAC, of course, is the estimate at completion, what we think it's actually going to cost. AC is the actual cost so far, in this case at the end of day 2. And ETC stands for the estimate to complete, how much more we think it's going to cost. In our case, EAC is $4,000 that's been spent so far, plus $9,000 that we expect to spend to finish, which totals up to $13,000. Similarly, using AT for actual time, the estimate at completion in terms of time rather than money is AT plus ETC in terms of time. That is 2 days of actual time plus 9 days of estimate to complete it, totaling up to 11 days. In other words, the forecast is that this project will be 1 day late and $3,000 over budget. Now let's take a look at the case in which only the cost problem has been fixed. Suppose that the extra costs and delays were due to the need for more training, and that you expect that each person on the team will now be able to scan at the rate and cost you had originally forecast, but that 2 of your 4 team members have been pulled away onto another project, so it will take twice as long as originally planned to finish the remaining work. In other words, the scheduled performance index of 50% will continue for the rest of the project. For this example, you've probably already figured this out in your head. Notice that because you don't expect the scheduled performance index to change, instead of calculating the estimate to completion first and then the estimate at completion, you can use the simpler continue as it has been formula. That is, you can simply take the planned duration of 10 days and divide it by 50% to get 20 days. But the formulas are ETC equals BAC minus EV, which equals $10,000 of budget to completion minus $1,000 of earned value so far, which equals $9,000 of estimate to complete, since the cost problem has been fixed. The estimate of completion is still the same as before, $13,000, because the cost problem has been solved now. In other words, the forecast is that the project will be 10 days late and $3,000 over budget. Now let's consider the case in which only the schedule problem has been fixed. Suppose that the extra costs and delays were due instead to the fact that the documents require much more time to scan because they need much more preparation and handling than expected. Rather than being the separate sheets you expected, most are stapled or bound. Some are more fragile and need to be scanned with different equipment. By the end of day 2, you have increased the size of the team and added the necessary equipment to be able to complete 10 boxes per day as planned, but that it will cost significantly more than planned, $4,000 per day instead of $1,000 per day. In other words, the cost performance index will continue as it has, so you can use the simpler formula for the cost forecast. That is, the budgeted completion of $10,000 divided by the cost performance index of 25%, or $40,000 to complete. Because the schedule is now back on track, we're only 1 day behind and will remain only 1 day behind until the end of the project. The third case is when you have to reestimate. Sometimes it's necessary to completely reestimate the project. Assumptions or constraints may have changed. Even if the scope hasn't changed, changes to other factors such as resource availability, quality requirements, or risk tolerance may make it necessary to reestimate and establish new baselines. In this case, you simply add what you've spent so far in time and money to your new estimates for what it will take to finish the project. Now let's review the forecasting formulas. We have 3 different situations and 3 different sets of formulas to deal with them. The first is if you believe the project will continue as it has been, then you can use the simplified formulas in which you simply take the original project budgeted time or cost and divide that by the appropriate performance index. In the second scenario, things have not gone according to plan, but you believe the problem has now been fixed. In this case, you have 2 components. You have what has happened, which you need to add to the remainder of what was planned. So you take the actual cost or time, and that accounts for the part that hasn't gone so well. And to that, you add what was left, or what is left, of the original plan. Now, it's not the same as what's left in the budget or what's left in the schedule, because things are already behind or ahead of schedule, or over or under cost. But it's the amount of work remaining measured in time or money. The third scenario is when things have changed so much that you can't count on the original plan anymore, and you have to completely re-estimate the remaining work, how much time and money it will cost to finish what's left. In which case, you take what has happened, the actual cost or time, and add that to your estimate of what you think will happen for the rest of the project. And now for the quiz. Number 1. A simple way to estimate what the project will cost is to A. Multiply the original project budget by the project's CPI, B. Multiply EAC by CPI, C. Divide the original project budget by the project's CPI, or D. Divide EAC by CPI. The correct answer is C. Divide the original project budget by the project's CPI. Remember, however, that this only applies in the simple case in which you expect the project to continue as it has been. Number 2. A simple way to estimate when a project will finish is to A. Multiply the original project duration by the project's SPI, B. Multiply EAC by SPI, C. Divide the original project duration by the project's SPI, or D. Divide EAC by SPI. The correct answer is C. Divide the original project duration by the project's SPI. Again, keep in mind that this only works if you believe that the project will continue as it has been. Number 3. VAC is A. the estimated difference in cost at the completion of the project. B, the estimated difference in schedule, measured in dollars, just as SV is measured in dollars, at the completion of the project. C, the difference between specified and measured quality. Or D, the variance in actual cost of work packages of equal planned value. The correct answer is A, the estimated difference in cost at the completion of the project. Number 4, ETC is the expected cost to finish all remaining project work, the expected total cost of the project, the ratio of earned to actual cost, or a measure of the effort to control quality. The answer is that ETC, or estimate to complete, is the expected cost to finish all remaining project work. Number 5, the total estimated project cost is BAC, EAC, ETC, or TCQ. The correct answer is EAC. Now be careful to distinguish between the total project budget and the estimated project budget. The total project budget is the approved baseline budget represented by BAC. The estimated project budget is your latest estimate or forecast represented by EAC, estimate at completion. Number 6, Robert has been asked by his manager to take over a project in distress. It is both behind schedule and over budget. Robert is able to identify and resolve several impediments that were preventing the project team from operating at their expected potential. Now that the project is back on track, how should Robert estimate the total cost of the project? A, multiply the original project budget by the CPI at the time he took over the project. B, subtract the earned value of the work completed at the time he took over the project from the original project budget, and add this to the project's expenses prior to his start. Or C, multiply the original project budget by the average of CPI and SPI at the time he took over the project. Or D, multiply the planned value of the remaining work by the weighted average of the old CPI and the new CPI, and add this to the actual cost of the work already completed. The correct answer is B. Subtract the earned value of work completed at the time he took over the project from the original project budget, and add this to the project expenses prior to his start. The formula is EAC equals AC plus BAC minus EV. This is the equation to use to re-estimate the total cost of the project when the project is already underway, expenses have been higher or lower than expected, but the rest of the project costs are expected to be what was originally estimated. In other words, this is the case in which a project has been off track, but now it's back on track. BAC minus EV is the amount of remaining work as originally estimated, and AC is the actual cost of work completed so far, which may be more or less than what was estimated. Number 7. Robert has been asked by his manager to take over a project in distress. It is both behind schedule and over budget. Robert assembles a new project team that he is confident has the appropriate skills for the project. Robert's manager asks for his assessment of what the project will cost. How should Robert estimate the total cost of the project? Should he multiply the original project budget by the CPI at the time he took over the project? Or subtract the earned value of work completed at the time he took over the project from the original project budget, and add this to the project's expenses prior to his start? Or multiply the original project budget by the average of CPI and SPI at the time he took over the project? Or have the new team provide a new estimate for the remaining work and add this to the project's expenses prior to his start? The answer is D. With an entirely new team, the old estimates and performance metrics are no longer applicable, so he will need to re-estimate. Number 8. The project budget is $500,000. The project is 3 months into its 6-month schedule. It was anticipated that $250,000 worth of the project would have been completed by now. So far, $240,000 has been spent to complete what was expected to cost $225,000 and was expected to take 2.5 months. What is the project's earned schedule SPI? I'll give you a moment to figure it out. If you need a bit more time, just pause the lesson. The answer is A, 0.83. Recall that SPI is the earned schedule divided by the actual time, which is 2.5 months of actual earned schedule divided by 3 months of time, or 0.83. This concludes part 3. The information in these earned value lessons is consistent with the Project Management Institute's PMBOK guide. However, the content itself is based on other publicly available sources and goes beyond what is found in the PMBOK guide. A list of such sources is provided at the end of the last lesson for those who are interested in further study.